right? If it was on rest, it start to move. It will either change its shape. When we apply some force on a rubber band, it will stretch and change its shape. And sometimes it also starts to rotate. Okay, these are some of the consequences that happens when we apply some force on an object. Okay, so the standard unit for the force that we use is Newton or kg meter per second square. This is the unit that we'll use in this entire chapter for the. Okay, and this is the symbol that we use is F. Okay, so next is, as I told in the previous slide, that when we apply a force on an object, what happens is the object will start to move. Object is moving means it has gained some weight, sorry, gained some speed, right? Gain some speed. We all are very familiar with the term speed, right? We know that a car is moving with some speed, some vehicle is moving with some particular speed. We also see speed on the meter that is present near the steering, right? And we call that meter as speedometer, which tells us what is the speed of the car. But to calculate the speed, mainly we have a formula. Okay, so this is a definition for the speed. The average speed of an object is the total distance traveled by an object divided by the time taken. So first what we will do is we will calculate the entire distance that the car has moved in some time. Okay, then we will divide these two entities and we will get something called as speed. Okay, so this is the formula for the speed. V is equal to S upon T. If V is speed, S is distance, and T is time. Okay, this is a very basic formula for the speed. Unit that we will use for the speed is meters per, where the distance is in meters and time is in seconds. If the what we call distance was in centimeters and the time was in seconds, then we will get unit as centimeter per second. And if the distance was in kilometers and the time is in hours, then we will get unit as kilometer per hour. Okay, so based on the formula we learned now, we will solve one problem. Okay, you all can try this. I will read it out for you all. A car travels 100 kilometers in 2 hours. So what is the average speed of a car? So we know the formula that V is equal to V is equal to distance upon time, right? Correct? V is equal to distance upon time. Here the distance is given 100 kilometers and time is given 2 hours. Correct? So just put these two quantities in this formula. The distance is 100 kilometers and the time is 2 hours. Just doing this simple calculation, we will get answer as 15 kilometers per hour. Correct? Did anybody get the answer? Just check your answers. Okay. So this was a very basic problem based on the speed. So now can you all see this chart that I have presented? This data is for a moving car. So at time 0, the distance is 0. At time 0.5 second, the distance is 6 meters. At time 1 second, the distance is 12 meters, and so on. Okay, so we know the final distance that a car has traveled in some time. So we can definitely put it in the formula and get the speed of the car. Okay, calculating it. But there is another way from which we can get the speed is by plotting a graph. And we call this graph as distance time graph. On the y-axis, we plot distance, and on x-axis, we plot time. Okay, so just plotting the data, I got a straight line. So straight line means a car is moving in a uniform motion. Uniform motion means it is covering some particular distance in a fixed interval of time. Okay, so this car has moved in a uniform motion. Okay, so if we just find the slope of this line, we will get nothing but speed. Okay, so these are the two ways we can calculate the speed, either using the formula and through the graphical method. So there are some of the distance time graph. We will see each one of them separately. So this distance time graph is of a car. Like we'll see the distance is not increasing at all. Is the distance increasing? No. But the time is constantly increasing. Okay. So from this we can predict that the car is stationary object. Okay. Whatever the vehicle is stationary or it is at rest. So this graph is for the object which is at rest. Okay. So distance is not increasing, time is constantly increasing. Then move to the next graph. Here we can see two straight lines. And in the last slide, I told you all that straight line means a uniform motion, right? So, but there are two lines. So, if there is object A, there is object B. That means this graph is for two different object moving. But object A is slightly higher than object B. That means that the object A is moving with a very high speed than object B. Okay, so this graph is for two different vehicles. The next graph is, let's see, the distance is increasing with time slowly, and then suddenly what happens is the distance has increased drastically, right? Drastically, the distance has increased. So that means we can say that this object is accelerating. Accelerating means the object caught up a very high speed suddenly, or the distance has increased drastically as compared to the time interval.